Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about surveys. Let's get started. All right, so surveys are used to collect information about a population or a group of individuals. So let's talk about some examples of surveys. When a company would like to know if a group of people will purchase a new product, they create a survey. When a teacher would like to know if her students will participate in an after-school science club, that would be another example of where someone might create a survey. Now, the first step in surveying a group of people is to write an unbiased question. Now, good survey questions are short and they're concise, and they usually begin with who, what, when, where, why, and how. The next step is to choose a random sample of participants. Now, you might want to write this definition down, both of them, in fact, the last one and this one. In a random sample, each member of a group has an equal chance at being asked to participate in the survey. After the results of the survey are in, statisticians analyze the data and use it to make estimates about groups of people. Then they can create a visual display of the data. So in this lesson, we're going to be talking about how to devise a survey question, how to choose a random sample of participants, how to choose an appropriate display for survey results, and how to analyze the data to make predictions about a group of individuals. Again, you might want to write these steps down in your math notebook. Let's look at an example. 25 households were asked to participate in a survey in which they were asked to approximate the number of hours they watch TV. Each day, the results of the survey are listed below. Determine the most appropriate display for the given data. And there's the number of hours each family said that they watch TV. So really, a frequency table and histogram will depict the most and least frequent number of hours of television watched. So let's do that. So here we go. In the interval of hours of TV, 0 to 1, the frequency was 5. 2 to 3 hours, the frequency was 8. 4 to 5 hours, the frequency was 9. And 6 to 7 hours, the frequency was 3. And there you can see it on the histogram. So now the next step is let's draw some conclusions based on the data and the display. Looking at the histogram, you can see that the majority of families that participated in the survey watch between 4 and 5 hours of TV each night. 5 families watch between 0 and 1 hours of TV each night. 8 families watch between 2 and 3 hours of TV nightly. And 3 of the 25 families watch between 6 and 7 hours of TV each night. It's a lot of TV. So now let's look at how to identify potentially biased samples and survey questions. Now, here's another definition that you might want to jot down. A population is a group about which you want information. Now, because it's impossible to survey an entire population, a sample, and that's another key term you want to write down there, a sample or part of the population is chosen to participate in the survey. The results from the sample group are used to make estimates about the population. And larger samples lead to more reliable estimates about the population. In a random sample, another term that you should definitely write down, each member of the population has an equal chance of being chosen to participate in the survey. Using random samples reduces the likelihood of bias. And it's important to create and conduct a survey without bias, as we saw in our last video. So how do we conduct a survey without bias? Well, the first way to prevent bias is to be sure that the participants are chosen randomly. So for example, if you're surveying high school students about their favorite sport, it'd be biased to take your only sample at the Friday night football game. Your survey results will be more valid and reliable, for example, if you survey every 5th student that walks through the hallway. The second way to prevent bias is to have a well-written survey question. Survey questions should be written clearly and concisely, as I said before, and they should begin with questions like who, what, when, where, why, where, or how. Let's look at an example. You'd like to conduct a survey to determine what activities middle school students like to do on the weekends. To ensure you have an unbiased sample, you should A, go to the mall and survey every 10th person that walks by, B, survey middle school students at a local movie theater, or C, survey every 5th person leaving each of your classes. That might have been a little easy for you all. C, yes, C is the best answer. You should avoid taking the survey at the mall and the movies because it's likely that those participants will say that the mall or the movies, that's their favorite activity. Let's look at another example. You survey every other person leaving a neighborhood pool. 89% of the participants support a proposal to purchase new chairs and umbrellas. Should you report that there's overwhelming support for your proposal? Well, let's take a look at what it says here. While there's overwhelming support for your proposal, the sample in which you took the survey, it's biased. It's likely that the people who use the pool frequently will support the idea of new chairs and umbrellas, and it would be wise to randomly sample other people from the neighborhood. Another example, you would like to know which types of dog food are most popular. You decide to wait outside 3 local pet food stores and interview every other person that comes out. Will your plan yield an unbiased sample? Yes. Now that's a better example. That's a good example of a survey question that's not biased. Now, it's best to survey participants for this particular question coming out of a pet food store because you know that they're there to purchase pet products. Conducting the survey at 3 stores would yield a larger sample, which will lead to even more reliable results. And you may also want to consider interviewing maybe like veterinarians or people that are at dog parks. So data is analyzed after it's collected and it's organized on a graph. Survey results are used to make predictions about a population. Here's another example. Remember we talked about this survey earlier, that 25 families were asked to state the number of hours they watch TV each day. Use the results from the survey to answer the questions on the next slide. What percentage of participants stated that they watch between 4 and 5 hours of TV per day? So basically, we're talking about how to turn these numbers into percentages. So let's take a look at what it says here. 9 participants out of 25 stated that they watch between 4 and 5 hours of TV per day. To determine the percentage, express 9 out of 25 as a fraction. This can then be converted into an equivalent fraction with a denominator of 100. To do so, multiply the numerator and denominator by 4. And you can see the math problem worked out there. 9 times 4 is 36, and 36 over 100, then that's pretty simple, would be 36%. So 36% of the participants stated that they watch between 4 and 5 hours of TV each day. All right, everyone, that does it for this lesson. Thanks for joining us, and we'll see you next time. Bye.